All right, this is part 3 of section 4.9 dealing with antiderivatives. In this video, I'll just talk about other indefinite intervals here, okay? And this is 7 through 12 for these indefinite intervals here. And you'll see on the left side are your derivatives, and on the right side are the corresponding integrals for those, like for the derivative of e to the ax, okay? The derivative of e to the x is simply e to the x. So e to the ax will be e to the ax times the inside derivative where you have to apply the chain rule. So it'll be the derivative of ax, which will be a. So e to the ax will have this derivative of as a times e to the ax. And then for the corresponding integral for e to the ax dx, it will be 1 over a times e to the ax plus c. And by the way, again, the integral of e to the ax is a simple integral to take, which is simply e to the x, since the derivative of e to the x is e to the x. Next is the derivative of b raised to the power of x. That's going to be b times the natural log of b. But if we take the integral of b to the x dx, you're going to get this. 1 over ln of b, which is your base, times b to the x, and then plus c. The restriction there is b has to be a positive integer other than 1, a positive constant other than 1. All right, for the natural log of x, its derivative will be 1 over x. Let's say we have d over x, dx divided by x, and we take that integral. It's going to be the natural log of the absolute value of x. Now, let me explain something to you on this one right here. I can write dx over x as x to the negative 1 times dx. If you recall back in the first video of this section, we cannot have this exponent to be negative 1 when we're taking the integral because it would be undefined. But now we do have this right here, ln of absolute value of x plus c, because x to the negative 1 is going to be 1 over x times dx, and we can take its integral as the natural log of the absolute value of x plus c. All right, the last 3 are your trigonometric functions here. The derivative, well, actually inverse trigonometric functions, I should say. So here, the derivative of the inverse sine of x over a would be this, 1 over the square root of a squared minus x squared. Now, if we take the integral of dx divided by the square root of a squared minus x squared, I would end up with the inverse sine of x over a plus c. And then for the inverse tangent of x over a, its derivative will be a divided by x a squared plus x squared. And then take its integral, dx over a squared plus x squared, it will be 1 over the constant a times the inverse tangent of x over a plus c. And then finally, for the inverse secant of the absolute value of x over a, its derivative will be a divided by x times the square root of x squared minus a squared. If we took the integral of dx over x squared times the square, x times the square root of x squared minus a, I would get 1 over a times the inverse secant of x over a plus c. And that's where a is greater than 0. A has to be positive. All right, so now we're going to apply these integrals for these examples that I have here. Let's say I want to find the following indefinite integral. And that's going to be the integral of 1 over 2b times dv. All right, now let's think about this for a moment. This 1 over 2 is going to be a constant. Here I can pull the 1/2 out in front of this integral. So I'm going to have 1/2 times the integral of, now I still got the v in the denominator, so I know I need a 1 in the numerator, so it'll be 1 over v dv. Well, guess what? I have something like this, the integral of dx over x, or 1 over x dx. If I take the integral of that, it's going to be the natural log of absolute value of x plus c. So the integral of 1 over v dv, if I bring the 1/2 over, I'm going to have the natural log of the absolute value of v plus the constant c. So 1 over the variable, you take its integral, it'll be the natural log of the absolute value of that variable plus c. So I'll end up with 1/2 ln of the absolute value of v plus c. Okay. All right, let's look at the next example. Let's say I have the integral of e to the 8x plus 3 times the square root of x dx. And let's say I want to check this by using differentiation. All right, so I need to use the sum rule and the constant multiple rule here. So in this case here, I'll break this up as the integral of e to the 8x dx plus, pull the 3 out in front, times the integral of, let me write the square root of x in exponential form, x to the 1/2 dx. Now I'm going to use that rule where I had the integral of e to the ax dx, which is this right here. That would be 1 over a, which is your coefficient of x, times e to the ax plus c. So I'm going to write that as, that 8 would be 1 over 8 e to the 8x for that part, and then plus, of course, I'm going to use the power rule here on this one right here. If you recall, back in the first video of section 4.9, we increased the power by 1, so the x to the 3/2, divide that by 3/2, which is your new exponent, and then plus c, since it's an indefinite integral. So I'll bring down the 1/8 e to the 8x plus, now if I do 3 divided by 3/2, that's 3 over 1 divided by 3/2. That'd be 3 over 1 times the reciprocal, which is 2/3. You'll see the 3's divide out. You'll be left with 2. So this will be 2x to the 3/2 power plus c. Now, of course, they want us to check by using differentiation. So if you were to do the check, it'd be the derivative with respect to x of 1/8 e to the 8x plus 2x to the 3/2 plus c. All right, so if I take that derivative, bring over the 1/8, the derivative of e to the 8x will be e to the 8x times this inner derivative, which is 8 plus, if I bring down the 2, bring the 3/2 down, copy over the x to the 1 less power, 3/2 minus 1 whole will be 1/2 plus c. Now, if I simplify this, these 8's divide out. You'll be left with e to the 8x. Actually, the derivative of a constant is 0, so I don't need that plus c, since the derivative of a constant is 0. And then plus 2's divide out, you'll be left with 3 times x to the 1/2 in radical form would be the square root of x, which is exactly the integrand that I have right here. So that integral will be 1/8 e to the 8x plus 2x to the 3/2 plus c. All right, next example 14. Determine the indefinite integral here. We got the integral of 3 divided by 49, the square root of 49 minus x squared dx. And let's say I want to check my answer by differentiation. So in this case here, let's say we got the integral. The integral of 3 divided by the square root of 49 minus x squared dx. All right, so the 3 is a constant. I can pull the constant out. Using that constant, multiple rules, will be 3 times the integral of, and I'll pull the dx in the numerator. That'll be divided by the square root of 49 minus x squared. There is an integral for that. And it follows this format, where a is a constant and then minus the x squared. I can use the inverse sign of x divided by a. Now I need to find out what a is in this case, because this part represents a square. And here a square is 49. So for a, you have to determine what number times itself will give me 49. It will have to be 7. So here a is going to be 7. All right, so I'm going to bring over the 3. The integral that we're dealing with for that would be the inverse sign of x over a. So the inverse sign of x, square root of x would just be x over a, which is 7. That's the square root of 49, by the way, and plus c. So I have 3 times the inverse sign of x over 7 plus c. Now let's check this by taking the derivative of this of our answer. So here's a check. So here, if I take the derivative with respect to x of 3 times the inverse sign of x over 7 plus c, well, I'll bring over the 3. And I was showing you this. I meant to show you this right here, but you do get the idea. That's going to be the inverse sign of x over a. But here, if I take that derivative, it would be 1 over a, and then that's going to be squared minus x squared underneath the radical. So it would be the 3 times, let's see, 1 over the square root of a in this case, that's the denominator, that's 7 squared minus the x, and that's going to be squared as well. So the 3 will be in the numerator over the square root of 7 squared, that's 49, minus x squared. And also the derivative of a constant is 0. And that is the integral that I came up with in this case. Okay, next example, example 15. If I can get to it. Let's say I want to determine the following indefinite interval. That's the integral of 9 divided by 64 plus t squared dt. Well, notice that the 9 is the constant in the numerator. I can pull that 9 out in front of the integral of This will be 1 over 64 plus t squared. Well, let's find the one that matches this. And it's going to look like this right here. The integral of dx over a squared plus x squared. A is a constant, so that means it's going to be 1 over that constant a times the inverse tangent of x over a plus c. And in this case, here's our a squared. That's a squared, 64. And since a squared is 64, what number times itself will give me 64? Has to be 8. So a then would be equal to 8 when we use this right here. And it has to be this right here because it doesn't have the square root in it. So it's going to be 1 over a, and a is 8. Let me bring the 9 over. Take this integral will be 1 over a, which is 1 over 8, times the inverse tangent of square root of t squared would just be t over a, which is 8, plus c. And then 9 times 1/8 would be 9 over 8. So it'd be 9/8 times the inverse tangent of t over 8 plus c. And if you will allow me to make my t's look like t's, okay. And so that's example 15. All right, let's look at example 16 on the next page. In this case here, we're going to evaluate the following indefinite interval. Let's say we got the integral of 7 plus u divided by u, du. Okay, what I'm going to do here is break this up into 2 parts. I'm going to divide 7 by u, and u will be divided by u. So this will be the integral of 7 over u plus u divided by u du. Okay, so here I got the integral of, let's do this. I'm going to pull the 7 out in front of that integral. So I'm going to have this 7 times the integral of 1 over u du plus the integral of u divided by u will be 1 du. So here I'm using a sum and difference rule for integrals, break them apart. Now, I already know what the integral of 1 over u du is going to have to be. It will have to be the natural log of x plus c in this case. But here, since I'm using a u, let's bring down the 7. And then that's going to be the natural log of the absolute value of u plus the integral of 1 du would just be u. And of course, it's an indefinite interval, so I must include the plus c each time. Okay. And example 17, here we're going to determine the following indefinite interval here. Let's say we got the integral of 15 t cubed minus 7 divided by t dt. Well, just like I did in that last example, I'm just going to break this apart, take each term, divide them by t. So I'm going to have the integral of 15t cubed divided by t minus 7 divided by t dt. And I'm going to pull the 15 out in front here. So this will be 15 times the integral of t cubed divided by t will be t squared dt. minus, then I'm going to pull the 7 out in front, times the integral of 1 over t dt. This first piece, I can apply the power rule by taking the integral of t squared dt. Here, I increase the power by 1, so it'll be t cubed divided by the new exponent of 3 minus 7. The integral of 1 over t dt, if you recall, from the last example, that's natural log of the absolute value of t. And then, of course, plus c, since it's an indefinite integral. So in this case here, if I divide 3 into 15, that's going to go 5 times. So I have 5t cubed minus 7 times the natural log of t plus c. Okay. So that would be the integral of 15t cubed minus 7 divided by t dt. 5t cubed minus 7 ln of the absolute value of t plus c. Okay. All right, I'll tell you what, I'm going to pause this video and do look out for part 4 of this video dealing with section 4.9. I'm going to be dealing with the introduction to differential equations. So be on the lookout for that.